Okay, welcome. This is a review for Chapter 11 quiz, and it's quiz 2. First question says, match the function with its graph. Well, if you recall, y equals, underneath the square root sign is the left and right shift. Remember, it's the opposite of what you think it's going to be. So since it's a minus 6, you're going to go this way 6 plus 6 that way. So you do the opposite. And then the up and down is whatever it says. So minus 1 means down 1. So we're going to take our parent graph, which is, we learned was 1 or 0, 0, 0, 1, 1. Sorry, let's fix that. Okay, so we want the graph that goes to the right 6 and down 1. This one here goes up 6, so that's not correct. That would be, this graph here would be y equals the square root of x plus 6. That's not what we have. This graph here is flipped over and moved over and shifted. This one we haven't even seen ones like this, but this would be negative x minus 6. I believe we're going to go plus 1, yeah. Here we have over 6 down 1, so this one is over positive 6 and down 1, so that one works. That's our answer. And here is going to be shifted that way. We shifted that way, and that's not what we're looking for. Okay, the next question is 2 equals, or y equals radical x minus 4. So we're gonna pick this one apart. Y equals radical x minus 4. Nothing under the radical, so it stays where it is. There's no right-left shift. However, there's a minus 4. That means go down 4. So which one of these graphs from the parent graph goes down 4? So it looks like it's this one here. This one goes to the right 4. Actually, let me write all these again. 4 is going to work. This one here is going to be a shift to the left. This would be y equals radical x plus 4 under the radical. This would be y equals radical x plus 4 on the outside. This would be y equals radical x minus 4 under the radical. And this one here is what we want, y equals radical x minus 4 on the outside. Okay, the next question, the negative 1 is under the radical, so it's a positive 1 shift that way, to the right. So if we look at the next set of graphs, so this one is a shift up. This would be radical x plus 1. This one is shifted down, radical x minus 1. Here we have radical x, and it goes this way, so it would be plus 1, and the last one is radical x minus 1. And I believe that was the correct answer, without looking back. Moving on to these questions here. We're going to divide 5 into 400, and we're going to get radical 80. That can be broken up into radical 16 times 4, or not, no, sorry, times 5. 50, yep. And that's going to be broken up into 4 radical 5. Here we have 2 plus 1 is 3 radical 6, all set. Here we don't have it broken down, but 63 breaks up into 7 and 9. So that gives us a 3 here, which we have to multiply by the 8. So it's 4 radical 7 plus 3 times 8 is 24 radical 7, which gives us 28 radical 7. Okay, number 7, we're going to get at the square root by itself, so we're going to add 8 to both sides. We add 8 to both sides, we get 12 equals radical m. To get m, we just square both sides, and 12 squared is 144, and m equals 144. Square root of m squared is 1. 144. So, I'm sorry, square root of m squared is m, which equals 144. Question number 8. We're going to do the same thing. The radical's by itself, so square both sides. You get r plus 5 equals 121. Minus 5 from each side, and r equals 116, right? Yes, 520, yep, 116. Then when I check it, if I plug in 116 into my equation, add 5 to it, I get 121. And then radical 121 is 11, so that checks out. Kind of going through these quick. This one here, when two radicals are set equal to each other, just set the two equations equal to each other and get your answer. I'm going to pause. Somebody's at the door. Okay, so we set them equal to each other, and we're going to get the x's by themselves and the numbers by themselves. Let's bring the negative 2x over to that side, and we're going to get 7 equals 3x minus 8. Then add 8 to both sides. Then you get 15 equals 3x. Divide both sides by 3, and you get x equals 5. Or 3 times 5 is 15. And then we can go ahead and check it. So it was 2 times 5 plus 7. Is that equal to 5 times 5 minus 8? And then we do the square root of both sides. And this is 17. Radical 17 equals radical 17. Checks. Okay, moving on to number 10 is the one that we're going to square both sides. And let's put this on a separate sheet. You're going to square both sides, and you're going to change the sign, put it in standard form, make the chart, get an answer. Okay, so let's look at this for number 10. So you have x, we need to show this work tomorrow, equals radical negative 3x plus 40. Square both sides, we get x squared equals negative 3x plus 40. Bring everything over to the x squared side. X squared, change the sign. 3x minus 40 equals 0. And this breaks up into a chart. Factors of negative 40 that add up to 3. I believe it's 8 and 5, and the 8 is positive, 5 is negative. And then what we said is do the opposite of this for your answer. So negative 8 and 5 are your answer. We're going to throw out the negative 8 because when we plug it in, it's going to get a negative for a square root. And then we're going to check the original with the 5. Is 5 equal to radical negative 3 times 5 plus 40? So basically, is 5 equal to radical negative 15 plus 40, which turns into 25, and that checks. So your answer is x equals 5. Now looking at the other question, number 11, we're just going to type in our calculator the sine of 66 degrees. Let me turn the calculator on. Sine of 66 degrees. So sine 66. Enter. I get 0.193545. So that's going to be my answer, 0.9135. 0.9135 to the nearest 10 thousandths. Okay, number 12 is a graph. I don't mind if you, on your graph paper tomorrow, graph the parent function and show the shift that you're going to go back for, because it's, I'm sorry, that's incorrect. We're going to go forward for. It's negative 4, because why? Because of the radical x plus 4 means go backwards negative 4, and then the minus 4 means go down negative 4. And then you're just going to have this move over and down, and the same function is right there. Okay. If we were doing this with the table wise, we would take x plus 4 and put greater than or equal to 0. X has to be greater than or equal to negative 4. Then we would use the table of negative 4, negative 3. Okay, so if we put in negative 4, so negative 4 plus 4 is radical 0 minus 4 is negative 4. And negative 3 plus 4 is radical 1, minus 4 is negative 3, and that's where we're getting these numbers from. Negative 4, negative 4, negative 3, negative 3, negative 3, and you got your graph that way. 13 is a foiling question. Use the box. So we're going to do 2 radical 5 and 3 radical 7 and multiply those two together. When I multiply these two together, I get 4 times 5. Multiply these together, I get 6 times radical 35. When I multiply these two together, I get 6 times radical 35. And when I multiply the last two together, I get 3 times 7, which is 21. Okay, so this is 15. I'm sorry, 20. This is 21. Together they make 41. Plus 6 radical 5 and 6 radical 5 is 12. I'm sorry, 12 radical 35. These two added together is 12 radical 35. Okay, the last question, we're going to bring the 1 over by addition. Add 1 to both sides, and you get radical 3x equals negative 4. If we square both sides, we get 3x equals 16. I'm sorry, that's not right. Negative 3x equals negative 3x equals radical 3x equals negative 3. Square both sides, we get 3x equals 9, x equals 3. But when you go to check this doesn't check. If I put a 3 in here, I get radical 3 times 3 minus 1. Does that equal negative 4? And the problem is it's not going to equal a negative 4. We're going to get 9 minus, I'm sorry, radical 9 minus 1 equals negative 4. You're going to get 3 minus 1, and that's not going to check. We needed this to be a negative 3. It doesn't check. Does not check. So no solution. No solution. Sorry, I went really quick on that video. Hopefully that helps. God bless you. Hope you do well.